Hi Math 5-4. This is the video for Lesson 101, which is scheduled for Monday, March 30th. It deals with tables and schedules. And for tables and schedules, I believe the best way to teach this is to look at the ones in your book, because that is what your practice problems are going to be on. To start out the lesson, just like we did in class, you should do your time test J, which is on page 205, in your test and worksheet book, and have your parents grade that. When you're done with that, you can start with the lesson. So I'm going to swap and look at the table in my book. I am on page 470 on lesson 101. Looking at this table right here. So let's just understand the table. Let's not worry about the questions or anything at this point. The first thing we need to do is understand our table. So we've done bar graphs, we've done circle graphs or pie graphs, and we've done line graphs that told us about information. So this is just another way to present information in a table. So if we look at this table and we go to understand it, if we look up here, the heights of major mountains, that is the title of this table. So that tells us what this table is going to talk about. It's going to talk about how tall some major mountains are. Over here, under the headings, it gives us mountain, feet, and meters. We can look at that and know under mountain, it's going to give us the name of the mountain. Under feet, it's going to give us the height of that mountain in feet. So for instance, if I look at Everest here, Mount Everest is 29,035 feet. And then it's going to give me meters. So if I look under meters, Mount Everest, and go across to meters, Mount Everest is 8,850 meters. So it gives me information about each mountain, both in the height of each mountain, both in feet and meters. So I can use that information to compare. If I wanted to look at it and say, which of these mountains is tallest? Well, remember the feet measurement is part of the US system of measurement. The meter measurement is part of the metric system. So we're a little more familiar with feet. So I would look at the feet measurement to look at which one's tallest. And then I'm just looking for the very highest number. So I can start with comparing the thousands numbers. I have 12,000, 14, 14, 19, 20, and 29. Well, look at that. They put them in order for us from shortest up to tallest. So that's fantastic. If I want to know the tallest mountain, I can go straight up to Everest and see that it's 29,000 feet, or a little over 29,000 feet. So that is a really cool deal that they put them in order for us, but we wouldn't know that unless we could understand this table. Okay, we can compare and say, we can do a math problem and say how many feet taller is Pikes Peak, which is 14,110 feet, compared to Mount Fuji. And we could do the math there and determine how many feet difference there are. We'll get the opportunity to do some of that in our practice problems. So let's look. So this is one of the tables. The other table in this lesson, the reason I'm going through these tables, if you're wondering, is because both of these tables are going to be used in our practice problems. So that's why I'm spending so much time on each table. I want to make sure we fully understand it before we go to our practice problems. Okay? Our next table, if you go to the next page in your book, is on page 471. This table says weekday schedule. And so if we look up in example 2 here, it tells us this is Michael follows this schedule on weekdays. So this is Michael's weekday schedule. Okay, everything in here. So if we look down the left column, it has different times, starting at 6:30 in the morning when he wakes up and gets dressed and makes his bed. And then it gives us different time frames, 7:30, 8 o'clock. Notice we're in the AM, and then we swap to PM, 12 PM. Around lunchtime, or noon is another word for 12 p.m., remember, noon, he eats lunch. And then 2:45 p.m. all the way down to 9 p.m. when he goes to bed, and it gives us the different activities he does at those times. So we're going to use those to figure out some information on our practice problems. And because this is using the tables in the book, I'm going to do your practice problems with you. So if we look at the bottom here of page, I'm still on page 471, where your practice problems are. It tells us to refer to the table, which is on page 470, and the schedule, which is on page 471, to answer the problems A through C. So the schedule gives us a daily schedule from Michael. The table was the one that we talked about that had the heights of mountains. And so if you have your book open to 471, both of them will be in front of you. I just can't fit both of them on the screen at the same time. Okay, so let's look at the first problem, letter A. Mount Kilimanjaro is how many meters taller than Mount Fuji? So we're going to come over to page 470, and we're going to find how tall is Mount, I'm going to put a K for Kilimanjaro, and how tall is Mount Fuji. I take notes on it, so that way I don't get lost as to what I'm looking for. So, Mount Kilimanjaro, and it's our problem, if we go back and read it really carefully, it says Mount Kilimanjaro on letter A is how many meters taller than Mount Fuji. So back on my height table, I'm not going to ignore the feet column completely and go to the meters column. And I come down to Mount Kilimanjaro and go across to meters. Mount Kilimanjaro is 5,895 meters. And my other one in problem A, my other mountain, was Mount Fuji. So I come down to find Mount Fuji, go across, I still am using the meters column, and it's 3,776 meters. Now, if I have this height of Mount Kilimanjaro, which is taller than Mount Fuji, and I want to find the difference in their height, when I find difference, I am subtracting. Okay, that's your keyword for subtracting. So I can start my subtraction problem. So 5 minus 6, we know we can't do that without borrowing, so we're going to mark out our 5, mark out our 9, and take 10 from our 9, and bring that over to our 5, okay, which makes this 15. Now I can work this problem. 15 minus 6, excuse me, is 9. 8 minus 7 is 1. 8 minus 7 is 1. 5 minus 3 is 2. So my answer is 2,119, but I'm not done yet because I have to put the units that I'm dealing with, which is meters, or you could just put M. Either one would work on that problem. Okay, so that's A. So let's do B together. B says Mount Everest, so I'm going to write down on my notes, I'm dealing with Mount Everest, or an E, is how many feet taller than Mount Matterhorn? I'm going to put an M for that one because there's only one that starts, well, there are two. So I'm going to put M-A so I know which one I'm dealing with. Okay, so Mount Everest compared to Mount Matterhorn. And this one wants my answer in feet. If I look at letter B, it tells me how Mount Everest is how many feet taller than Matterhorn. So I want to be sure I'm dealing with feet. So I'm going to come back over to come here, trying to make sure everything's showing in the screen for you. And I'm going to compare Mount Everest, which is how many feet? It is 29,035 feet. And my other mountain is Mount Matterhorn. I'm looking at feet, and it is 14,691 feet. Or you could put FT. FT means feet also. Okay? So when I subtract that, I start subtraction, and 5 minus, and oh, let me explain why I'm subtracting, I'm sorry. So the reason I'm subtracting again is because I'm trying to find, I said Mount Everest is how many feet taller than Mount Matterhorn. So I'm trying to find the difference between Mount Everest and Mount Matterhorn. When we are finding a difference, we are subtracting. Okay, so 5 minus 1 is 4. 3 minus 9. So, oh wait, I can't do that quite yet. So I come forward to the next digit, but I can't borrow there either. So I have to scratch that one out. And I have to go to the next digit to borrow because I can't borrow from a 0. So I take my 9, turn it into an 8, bring my 10 forward. But I still haven't solved my problem over here that I can't subtract 3 minus 9. So now I'm going to take my 10, bring it down to a 9, and add my 10 here to make this 13. 13 minus 9 is 4. 9 minus 6 is 3. 8 minus 4 is 4. 2 minus 1 is 1. So then I'd go from the right and count 1, 2, 3, comma, and put my answer in my units that I'm looking for, which my question was asking for feet. So my answer on the difference between the height of Mount Everest and Mount Matterhorn in feet is 14,344 feet. So Mount Everest is 14,344 feet taller than Mount Matterhorn. So now if I move on to C, C says, how much sleep, let me make sure I get it on the screen for you. How much sleep does Michael get on a weeknight if he follows his schedule? So now we're talking about Michael. So we're done with our mountains and we're moving over here to Michael's weekly schedule. Let me bring that down a little bit. So we're looking at his weekly schedule and we're seeing how much sleep does he get on a weeknight. This is his weekday schedule, so a weeknight would be the night of. So we can look at, with Michael, and see what we know about. Well, we know that Michael on a weekday goes to bed at 9 o'clock p.m. So I'm going to write that down. 9 p.m. he goes to bed. Okay? And then we know our schedule, if we look through all his activities, it also tells us when he wakes up. He wakes up at 6:30 a.m. on a weeknight. So I'm going to put that down too. Okay? That's when he wakes up. So from the time he goes to bed until the time he wakes up, he's asleep. So now we just have to count hours. So if we start at the time he goes to bed until he wakes up to count the hours, if we start, and I use my fingers for this, and that's okay. So if we start at 9 p.m., he sleeps till 10 p.m., 11 p.m., 12 a.m., which is midnight, 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m., 6 a.m. He's still not awake at 6 a.m. I'm at 9 hours. If you can see my fingers counting, I'm at 9 hours. And he's still not awake there at 6 a.m. He sleeps an extra 30 minutes past that. So I have 9 hours already counted, which gets me to 6 a.m. But he's still not up. He is not up till for another 30 minutes. Because from 6 a.m. to 6:30 a.m. is 30 minutes. So his total sleep time is 9 hours and 30 minutes. Okay? And we use that all based on his daily schedule. Let's see, is that all the practice problems? That is. That is all the practice problems for lesson 101. I thought using the schedule and the tables, it'd just be easier for us to do them together. That's probably what we would have done if we could actually be together in class. So I hope each of you are doing well. I miss you, and if you need anything, please have your parents text me or call me or email me or get in contact with me somewhere. There will be a video coming for lesson 102 and a video coming for lesson 103. If we were in class together, we would do on Monday, we'd have done 101, 102, and 103. So those will be coming your way.